Hello Slaters, hope you all are doing well. In the previous class, we discussed about the factors and multiples. Today, we are going to discuss some more interesting concepts in playing with numbers. Now, let's get started. We shall try to understand what are the perfect numbers with the help of an example. What are the factors of 6? The factors of 6 are 1, 2, 3 and 6. When we find the sum of these factors, we get 12. 12 is 2 times 6. That is twice the given number. So, sum of the factors of 6 is twice the given number. That is 2 into 6 is 12. So, we say that 6 is the perfect number. So, how do we define a perfect number? A number whose sum of factors is twice of itself is called a perfect number. Let's understand with another example. If we take the factors of 28, they are 1, 2, 4, 7, 14 and 28. The sum of the factors is equal to 1 plus 2 plus 4 plus 7 plus 14 plus 28, which is equal to 56. 56 is twice 28. That is 28 into 2 is equal to 56. We can observe that the sum of the factors of a number is twice the number. Therefore, 28 is the perfect number. Now, let's discuss about the even numbers and odd numbers. Any natural number which is exactly divisible by 2 is an even number. For example, 2, 4, 6, 8, etc. These numbers are exactly divisible by 2 without leaving any remainder. So, we call them as even numbers, and even numbers are infinite. So, even numbers is defined as natural numbers that are exactly divisible by 2 are called even numbers. Natural numbers that are not exactly divisible by 2 are called odd numbers. For example, 1, 3, 5, 7, etc. These numbers are not exactly divisible by 2, hence they are called odd numbers. And they are infinite. All natural numbers are either odd or even. A number cannot be odd as well as even. Now let's see some important points. Sum of two even numbers is always an even number. Let's check this statement with an example. When we take two even numbers like 2 and 8, the sum is 10. 10 is also an even number. Let's check with another example. 12 and 14, where both are even numbers. When we add them, we get 26. So 26 is also an even number. Hence, it is proved that the sum of two even numbers is always an even number. The next important point is sum of two odd numbers is always an even number. Now let's verify this statement. We shall take two odd numbers like 5 and 7. Their sum is 12. 12 is an even number. So here when we are adding two odd numbers, we are getting an even number. In the same way, we take 19 and 21, which are odd numbers. Their sum is equal to 40. 40 is an even number. So when we are adding two odd numbers, we are getting an even number. Hence, we can say that sum of two odd numbers is always an even number. What if one number is an even number and another is odd? Let's check with an example first. 3 is an odd number, 6 is an even number. When we add both, we get 9. What is 9? Is it an even number or odd number? It is an odd number. So, we say that sum of an even and an odd number is always an odd number. Let's check with another example. 7 plus 10, where 7 is an odd number and 10 is an even number. Their sum is 17, which is an odd number. Sum of an even and an odd number is always an odd number. Observe the following table. We can observe that 1 has only one factor, and there are some numbers which have only two factors, that is 1 and the number itself. The other numbers have more than two factors. Now let's discuss about these numbers given in the table. Here 2 has two factors, that is 1 and 2. The number 3 has 1 and 3 as their factors. Number 5 has 1 and 5 as its factors, and 7 has 1 and 7 as its factors. So these are the numbers which have only two factors, that is 1 and the number itself. So such kind of numbers which have only two factors, that is 1 and the number itself, are called the prime numbers. There are some other numbers which have more than two factors. For example, 4 has 3 factors. 6 has 4 factors. 8 has 4 factors, and 9 has 3 factors. 10 has 4 factors. So, these numbers which have more than 2 factors are called composite numbers. Then what about 1? 1 has only one factor. So we can say that 1 is neither prime nor composite because it does not satisfy any of these conditions. Now let's define the prime numbers and composite numbers. The numbers having only two factors, that is 1 and number itself, are called prime numbers. That is 2, 3, 5, 7, etc. are prime numbers and they are infinite. Now let's define composite numbers. The numbers having more than two factors are called composite numbers. That is 4, 6, 8, 9, etc. are composite numbers and they are infinite. Note that 1 is neither prime nor composite. So, we understood that to find the prime number or a composite number, we should know the factors of a number. There is a method which is used to find the prime numbers from 1 to 100 without finding the factors of a number. Shall we discuss how? By using the sieve of Eratosthenes. In the 3rd century, the Greek mathematician Eratosthenes gave a simple way of finding prime numbers and composite numbers from 1 to 100 without finding the factors of a number. This method of sieving or separating prime numbers from composite numbers is called the sieve of Eratosthenes. Let's discuss the steps to be followed in order to find the prime numbers using the sieve of Eratosthenes. The first step is list all the numbers from 1 to 100. Then cross out 1 as it is neither prime nor composite. The next step is encircle 2 and cross out every multiple of 2 other than 2. That is 4, 6, 8 and so on. The next uncircled number is 3. Now encircle 3 and cross out every multiple of 3 other than 3 itself. Ignore the previously crossed out numbers like 6, 12, 18, etc. The next uncrossed number is 5. Encircle 5 and cross out every multiple of 5 other than 5 itself. Ignore the previously crossed out numbers like 10, 15, 20, etc. Continue this process till every number in the list is encircled or crossed out. In this list, we observe the following. All the numbers that are encircled are prime numbers and all the numbers that are crossed out except 1 are composite numbers. This method of sieving or separating prime numbers from composite numbers is called the sieve of Eratosthenes. Coprimes or relatively prime. The two numbers having only 1 as the common factor are called coprimes or relatively prime. Example, 5 and 8 are coprimes. The factors of 5 are 1 and 5. The factors of 8 are 1, 2, 4 and 8. And their common factor is only 1. So, we say that 5 and 8 are coprimes. Note that any two prime numbers are coprimes, but all the coprimes need not be primes. Let's see what are twin primes. The prime numbers whose difference is 2 are called twin primes. For example, 3 and 5 are the prime numbers whose difference is 2. 5 minus 3 is equal to 2. So, we say that 3 and 5 are twin primes. In the same way, 5 and 7 are the prime numbers whose difference is 2. So, 5 and 7 are also twin primes. Note that all twin primes are coprimes, but all the coprimes need not be twin primes. Prime triplet. A set of 3 consecutive prime numbers differing by 2 is called a prime triplet. The only prime triplet known so far is 3, 5, 7. 3, 5, 7 are the 3 consecutive prime numbers and Their difference between them is also 2. That is 7 minus 5 is 2 and 5 minus 3 is 2. Hence, this is the only prime triplet known so far. That is 3, 5 and 7. Hope you all understood all the concepts and prepared the notes. We shall learn more concepts in the next class. Thank you.